Now let's look at the inverse cosine graph. So here we have y equals cosine x, where x is a trig value. X is an angle. I'm thinking of the inverse function. X is an angle, and y is a trig value. If we look at the inverse function, y equals inverse cosine of x. Now x is the trig value, and y is the angle. So they've switched places. Just like with sine, we're going to pick an angle to look at that's really easy to spot on the graph. So I'm going to look at a 60-degree angle, because in a 60-degree angle, the adjacent side is 1 and the hypotenuse is 2. So cosine of 60 is 1/2, cosine of 1, and then these other angles all have 60-degree reference angles, so they're going to either be positive or negative 1/2. So let's look at, here's 60 degrees, 1/2. Notice we have another angle just on the opposite side of the y-axis that is negative 60 degrees, 1/2, showing that this is, that cosine is an even function. Opposite inputs give me the same output. I can see over here that cosine of 300 also equals 1/2, and negative 300 also would equal 1/2. Now let's look at some angles that equal negative 1/2. Cosine of 120 equals negative 1/2, as does cosine of 240. So both of these are negative 1/2. And we can see that there are their opposites on the other side of the y-axis also equal negative 1/2. So once again, we have multiple angles that equal positive 1/2 and multiple angles whose cosine value is negative 1/2. So if we look at our inverse function and we start with positive 1/2, we can mark the same four angles that we see on the original cosine graph that all have cosine values of 1/2. And we can do the same thing for negative 1/2. Negative 1/2, we see these four angles that all have the same negative 1/2 cosine value. So I'm going to label a couple of these. I see here that I have 1/2 60 degrees, and here I have negative 1/2 60 degrees. So stopping right here, you can see I'm not going to be able to use negative 90 to 90 as my inverse cosine function principal angles, because my trig value 0.5 already has two different y values that go with it. So I'm not going to be able to use that section of the graph. I need a section of the graph for which every trig value has only one angle and it includes all the trig values. So I can use this section from 0 to 90, but I'm going to need a different section for the negative trig values. It would make sense to just continue on from 90 to 180 and use this middle section of the graph right here as my inverse trig function. So let's see how that works. Are those the values we get? So let's label a couple of this. This would be negative 1/2, 120. And then a couple of other points that we would have if this were the right section. This point should be the point 1, 0, and this point should be negative 1, 180. And then right in the middle here we would have 0, 90. So these would all be key points that we would get if we did those on the calculator to see if that was the section that we need for inverse cosine. So let's go ahead and fill in here. We have, and I'll just use 0.5 here then. This would be negative 0.5, negative 0.5, and positive 0.5 based on what we have over here reading off the graph. But let's check these on the calculator and then also check some of those extra ones. Inverse cosine of 1, inverse cosine of 0, and inverse cosine of negative 1, to double check that this is indeed the section that we would use for inverse cosine. So let me get my sine ones off of here. So cosine of 60, we'll just double check this. Cosine of 60 is 1/2. Inverse cosine of 1/2, 60. Okay, so we're good so far. Cosine of 120 equals negative 1/2. Inverse cosine of negative 1/2 equals 120. Okay, so 60 and 120, both in that 0 to 180 section. Now let's do a few more inverse cosines. Inverse cosine of 1, 0, as expected. Inverse cosine of 0 is 90. Inverse cosine of negative 1, 180. Okay, so that indeed is the correct section that we've picked out. Let me go ahead and write some of these down. We got 60 for inverse cosine of 0.5, and that's the same 60 degrees we would get down here. Cosine of 300 is a quadrant 4 angle. Cosine is positive in quadrant 4, but when I do inverse cosine, it reverts me back to quadrant 1. Cosine of 120 is a negative trig value. That's in quadrant 2, and I get 120 back when I do inverse cosine of negative 0.5. But when I do a quadrant 3 angle where cosine's also negative, it reverts me back to a quadrant 2 angle. So all the angles that I get seem to be between 0 and 180 in quadrants 1 and 2 on a circle diagram. So I'm going to kind of fill this in here. We found that inverse cosine of 1 is 0, inverse cosine of 0 is 90, and inverse cosine of negative 1 is 180. Further confirming that this is the correct section for the inverse graph. So I'm going to kind of put a box around. Oh, that was a little bit too tall. But okay, so we go from, we don't include this point, but it's just from here, from 0 to 180 on the y-axis. So let's go ahead and take a look at our domain and ranges. So for inverse, or for regular cosine has the same domain and range as sine does. Angles and trig values. Oops. Inverse cosine has the same domain as inverse sine, negative 1 to 1, but its range is different. So the principal angles for inverse cosine aren't negative 90 to 90, they are 0 to 180. And if we were in radians, that would be 0 to pi, or 0 to 3.14 radians. Now, why we have different angles for cosine should be obvious when we make our little circle diagram. If I want to find angles that have a positive cosine value, I can just go to quadrant 1 like every other trig function. If I want to find angles that have a negative cosine value, I can't go to quadrant 4 because cosine is also positive in quadrant 4. So I have to find the next quadrant that has negative cosine values, and that is in quadrant 2. So my angles from 90 to 180 give me are the ones that correspond with the negative cosine values. So my principal angles are from 0 to 180.